Okay, so now we're focusing on outputs. So the area would be your output, and then the side length is going to be your input. Actually, let me put this little arrow over here. Okay, so side length. So if I look at input-output pairs, well, 0, 0. If I have a side length of 2, I'm just going to pick some easier values here. If I have a side length of 2, I'm going to have an area of 4. If I have a side length of 3, I have an input of, or an output rather, of 9. So just some values, and again, we've done this before in that table. So earlier we described the set of all possible input values as A, as any number greater than or equal to 0. So I could pick any number greater than or equal to 0. So then what is my possible values for outputs? So outputs could be, also if we look at from here, all values greater than or equal to 0. We go down to number 2. Function R is defined by R of n equals 40n, where n is the number of campers. So again, there's our input, and we're focusing on our output. So what you should be noticing about our output is that if we have the number of campers of 1, then we're going to have $40 for the revenue, or the amount in dollars. So is 20 a possible output value in this situation? So let's think about that. If we have 1 student or 1 camper, 1, so R of 1 equals 40 times 1, so R of 1 equals 40. So if I have 1 camper, it's going to be $40. So then R of 2 is going to be twice that, which is going to be $80. R of 3 is going to be another $40, which is $120. So let's answer the question, is 20 a possible output value in this situation? And the answer is no, because it needs to go by multiples of 40. Same thing about 100. Can I possibly get an output of 100? And we went from 40 with one camper, 80 with 2 campers, and then we jumped all the way to 120 with 3 campers. So the answer is no. So we are not getting that multiple of 40. Here are 2 graphs that relate number of students and camp revenue in dollars. Which graph could represent the function R? Explain why the other one could not represent the function. So if you're looking at this and you think of the input-output pairs, if I pick this value right here, can we have a fractional number of students? No. So if we look over at this one, if we have 5 students, we have a revenue of $200. If we have 6 students, we have a revenue of, it's going to be $240. So we're using this function notation. If I have 7, and that's going to give me my $280. So what we're noticing is that all of these inputs, so the inputs, and I'm just going to label those as X. So X has to be greater than or equal to 5, and X has to be less than or equal to 16. So this is actually called a compound inequality, and you'll be seeing more of those. And then if we look at the outputs, so they have to be multiples of 40, multiples of 40. So it's going to be between $200 and $640. Because 16 times your 40 gives you your 640. So when you're thinking about labeling your axes, think about number of students. What does that look like? What kind of values can I have for inputs? And based off of my function rule, then what kind of outputs am I going to have? So I'm not going to have values from 0 to 700 because of my function rule. It's going to have to be multiples of 40 each time. So here are the two graphs. Which graph could represent? It is going to be the second one.